Suddenly, we're inundated with claims about artificial intelligence, smart kettles, smart houses and cities, self-parking cars, and every cloud service now seems to be claiming some AI or machine learning capability. For Jeremiah Caron, GlobalData Technology Group's head of research and analysis, it is time to put aside the hype and grandiose claims and consider what we and the marketeers actually mean by intelligence and how far we really are from that promised land. In this podcast, he raises key questions and presents recent data on projected spending on versus practical application of AI by business before introducing three other speakers. Professor David Sheridan has taught computer science at Standford University since 1981 and is also a highly successful investor, entrepreneur, and philanthropist. He created the Distributed Systems Group at Stanford, was advisor and pioneer investor in Google. He co-founded Granite Systems, acquired by Cisco Systems, was one of the first angel investors in VMware, and co-founder and chief scientist of Arista Networks. Cheriton has founded and invested in more than 20 startups and is currently chief scientist and investor in Apstra, a pioneer in intent-based networking. Ravi Chandrasekaran is Cisco's senior vice president of enterprise networking business. He has considerable experience in the role of AI in supporting network management and security, and he is quoted saying that while the Industrial Revolution liberated humans from the limits of their physical capabilities, the digital revolution is going to liberate us from the limits of our mental capabilities. Bringing the discussion right down to earth in terms of practical business benefit, we have Nick Menemy, CEO of Renutrack, a company using extensive machine learning to automate its support maintenance and licensing renewal service. He argues for an important but often overlooked distinction: people talking about artificial intelligence when they're really talking about automated intelligent behavior. So now, over to you, Jeremiah Caron.
I'm Jerry Caron. I'm the head of research and analysis for a company called GlobalData, and we look at we provide advisory services and market data solutions across the whole tech and telecom spectrum, and so that's who I am. That's my role. But what I'm doing today, what I'm doing now, is I have the great pleasure to lead a discussion with the three panel members you see here, generally on the subject of AI. And I think it's a bit scary. When I saw that, I was like, well, it's really going to be impossible to talk about AI in 30 minutes. But what we really need to be doing is to drill down, and we'll talk a little bit about a definition around that term. But really, the objective here is to talk about the promise of AI and what is actually being delivered. What are the tactical, practical uses today, and what we can see in the short term going forward, and also what problems AI is solving today. Obviously, Ravi touched a bit on that just now in the networking context. Just a quick thought from me before I turn it over to the panel members. We do lots of work on AI-related topics. You talk about data science, you talk about machine learning, computer vision is a big one, and really, a very recent study just came out last week, a large global study of enterprise decision makers, not just IT people, but also just technology decision makers generally. And there's huge interest in these areas, huge expectation on spending money in these areas. Over 70% in data science, for example, nearly 70% in machine learning, and over 60% in computer vision type applications. So there's a recognition that this is going to be really important. But what I found fascinating was the same study came back with less than 50%. Surprisingly low number, 47% to be specific, said that only that amount said that AI would be very important to their businesses going forward. You would think it'd be a lot higher than that, wouldn't you? And I know why that is. The reason is because companies don't necessarily think about AI they want to think about what AI will do, so applied AI. That's actually what they care about. And so that's just a couple of thoughts there. So let me quickly introduce the panel, and I think the best way to do it is to have the panel introduce themselves. So starting directly to my right, let's start with Nick. Could you please let people know?
Hi, I'm Nick Menemy. I founded a company called Renutrack. We are a fully automated white label business which pursues support, maintenance and licensing renewals. Sounds really turgid and very dumb. But at the back end here, and it's interesting, I spoke before about this, we're using a lot of machine learning. We don't use AI per se, and we can talk about that when we get into discussion. But we're using a lot of machine learning to drive a better renewal rate. Ultimately, drive more revenue by using smart automation for the companies we work for.
Okay, Ravi, just to reiterate, I think they know who you are.
I'm Ravi Chandra, so I'm responsible for enterprise networking engineering in Cisco.
Okay, and David?
David Sheridan, and I'm a professor at Standford University. I'm actually not responsible for anything at this point. I think that I've been at Stanford for 38 years and worked with AI people, but I'm more of an AI skeptic. I've been involved in networking. I started a company that got bought by Cisco, spent some fun years at Cisco, and then I was a co-founder of a company called Arista Networks, which I guess has gone on to try and compete with Cisco, and I've been a co-founder of a company called Apstra, which I think is represented here, that's going on to tackle next level of management on top of Cisco and Arista and everybody else's switches to try and improve the network management situation. But I think my role here is to be the AI skeptic in part.
Okay, all right. Well, we'll dive in a second. Just for those of you who don't know, David's been slightly humble. He's, in addition to all those great things that he's mentioned, he also was one of the early funders of Google and also of VMware. And of course, as he mentioned, founded Arista with some others as well. So great honor to have you here with us, David. So let's dive into the conversation. So let's talk about this AI skepticism. Nick, I know you want to touch on that too. And I think it comes down a bit to the definitions, of what we're actually going here. So first, Nick, David started the conversation on skepticism. So why don't you give your thoughts on why you're a skeptic? And I know Nick wants to jump in as well on it as well.
Yeah. Well, I think one of the advantages of being older is you've been through a bunch of cycles and business cycles and market cycles. Well, I've been through a bunch of AI hype cycles. And, back in the 60s, the view was we're just on the edge of producing machine intelligence. And then it kind of died out when that didn't go anyplace. And then in the late 80s, the view was, well, expert systems were going to take over the universe. And, there was some very impressive projects done at Standford there, and there was great concern that the Japanese, with their 5th generation computer project, some of you might be old enough to remember that, were going to just dramatically leapfrog the US in technology. Well, what followed from all of these is there's a term referred to as the AI winter, when people have asked me over the last 35 years at Stanford what I thought of AI, I said, well, it's a very promising technology. It's been promising ever since I encountered it and continues to promise. I think it suffers from being over-promising. So I think that, for me, this is, as Yogi Berra would say, deja vu all over again, where you look at the excitement over AI and you look at all these articles that say, well, people are going to be thrown out of jobs and AI machines will take over the universe and so on. Well, I've been there, seen that, and then what follows is an AI winter. So there's a certain basis for skepticism just on experience.
Okay, thanks. Nick, I know you have some thoughts on this as well from your perspective.
I agree with David. And I also think you've got the hype cycle is an inevitability of the tech industry. I think we live through that every day. And I think we've come to use the term AI as a catch-all for everything which is a machine is going to automate something. So it's interesting, and I turn up and I'm quite specific when I talk about we do renewals automation, and there's some smart stuff there. And a lot of people go, oh my God, that's AI. I'm loath to agree, because just don't see that. Now, there is a place, and to David's point, there's a place where some of the tech associated with automating stuff in a smart way may have an impact in freeing up humans to do stuff they really want to do. Because ultimately, all this automation, all this machine learning stuff we're trying to do is to make what we do every day easier, faster, better, more accurate, etc., etc. But I don't see AI as the great nirvana which is coming this week, next week. You know, I laugh to a degree, and we had this conversation before, that you see some companies using the term willy-nilly, and there's probably around a fundraising due, or they've had a bad quarterly analyst report, or they've got to go to the street next quarter and announce bad results, and all of a sudden AI is flavour of the day. So to a degree, I have skepticism, but I've got reality. You know, I don't have a hedge position. I'm not a Cisco. I'm not an Arista. I can't go and buy another company just in case AI is the next thing. So to a degree, I'm sceptical, but I'm also realistic that there are elements of what people are calling AI, which are pervading the industry. Certainly, what we do is people are using it. It works, and it's machine led. So,
yeah, I mean, it's an umbrella term used to describe lots of different technologies and lots of different applications that in turn use those technologies, and that's probably confusing in a lot of ways. Ravi, do you have a comment on this issue?
I think it's all has to do with what we mean by AI. You know, it's not going to take over everything we're trying to do. In Cisco, we have a very simple view. We view these as tools that assist in certain things which we will not otherwise be able to do. Even, for example, when I talked about the closed loop system, there is a perception or perceived notion that automatically somehow AI is going to make the closed loop happen. We don't believe in that. That's why I had in that picture I was showing there is an ITSM system in the middle. There are policies and procedures that people do, and you need to take that into account. So we look at AI, and I even use the term internally, is more like an applied AI. It's not like, you know, all of a sudden changing something. You're just using that as a tool. Like the examples I told, like for example, if you look at the encrypted traffic, you need some assist. You can't easily find out what is inside. So we look at that way. So I think the moderation will start setting in, the reality will set in, where the answer is somewhere in between. It is not nothing, but it is not the glory that people talk about. It's somewhere in between, and we are starting to see some good results of that. So we believe these to be tools that it's going to be used everywhere, and the hype cycle will settle down. I think that's what should happen.
Despite the skepticism, David, would you agree that there are things that we need to do now, like cybersecurity and perhaps some large telco-style networks that absolutely demand sort of what we would generally call AI solutions?
Well, I think, again, there's a lot of value in figuring out where the pony is in this pile of hay, so to speak. And, you know, having lived with AI people, so to speak, for 40 years, their interest is replicating human intelligence. And my view, us humans are relatively stupid, relatively slow, and relatively unreliable at almost any given task. And you know, if you look at the history, you know, we used to have people who computed trajectory tables, and they did this math in their head, and then we thought that that was intelligent. And now we have computers that do it 1 billion times faster than human beings. And you know, you look at chess, we used to think that was an intelligent activity. Well, you know, of the 7 billion people on the planet, computers can beat every one of us. So, you know, this objective of human intelligence is a little misguided. I think you need to shift it, as Ravi is saying, to say, well, is there a pony in there, and can you apply it? That is, when you apply good engineering principles, does this technique apply? Is this the best approach? And, you know, and you look at security, playing my role as a skeptic, there was an article in a technical journal recently pointing out with machine learning how easy it was to fool it. And one of the examples, it showed 2 pictures, one of a stop sign and one of a stop sign. Just the one on this hand had been modified by an adversary slightly. So for a human being, they both look like stop signs. For this system, a vision system that had been carefully trained with deep learning to recognize stop signs and traffic signs, this was a stop sign, this was a yield sign. And you think, wait a minute, like, how did it get fooled? Well, because it's using statistical inference, if you statistically perturb the image in a way which is not detectable really by a human being, you can fuel this training that this thing has gone under. Now, in many, many cases, we want predictable performance. In fact, I'd say that's what engineering is all about, is you build things with predictable performance. I used to tell my students the reason people want predictable performance is because unpredictable is so horrible. Well, if you have a system where it thinks sometimes it thinks that a stop sign is a yield sign, and you try and put this in a self-driving car, you have a big problem. And in some ways, it's a security problem. So I think one of the things we have to tread very carefully on is that security is not a one-time event. Security is an arms race. And so you do this, I'm going to counter with that. You do that, I can counter with that. With machine learning, we don't understand how to counter adversaries. And the striking thing about this article was it was written by a Google expert in machine learning, and the end of the article had no answers to this problem. So I think we can't ignore these techniques, but we have to tread carefully.
Yeah, and just if I could segue real quick, because you quickly get into the human discussion when any conversation about automation or AI, and I think that now that we've all agreed with David's encouragement that humans are pretty bad at a lot of things, Ravi, particularly perhaps secure network management and automation in today's world, perhaps Cisco would argue. What's that mean for the army of Cisco experts out there and their future and what needs to happen? What's the human side from your perspective? And then Nick, I'd like to hear what you think about that as well.
Yeah, when we look at it, if you look at any IT organization, they're not growing. They're not adding hundreds of people to run the network or the digitization that's happening. So what we see that is that the tooling we're providing, the automation and all the security related things we're providing is basically to free them up from dealing with the complexity that comes along so that they actually can get their job done. So we look at all this automation when I talk about or the security infrastructure we're building or the whole help we are giving with toolings we are doing with AI, ML, whatever it is around to free people so that they don't get completely buried with the burden that's coming along with the number of devices coming on board or the change set that is being asked in this new world. So to us, we feel this, when we talk to any of the CIOs or IT organization, they're so happy we're providing the tooling because without that, they cannot keep up. They cannot run the infrastructure. It's not like they're getting more people. So if some company goes and say, I'm going to digitize or going to do a new world, they're not saying I'm going to all of a sudden double my IT budget. IT budget still continues to stay where it stays. So you need these help. So we look at it, and when we talk to our customers, they understand it. They understand these are the tools that you need to have to run the infrastructure. So it's not trying to replace people. It's not trying to reduce the people. It is freeing up so that they can be a business relevant. So that's how we see it.
And presumably the skilling, both at the early stage in educational environments and also later more within your reseller partners, et cetera. Presumably that's well underway.
Absolutely. Any Cisco program, whether it is DevNet or whether you look at CCA, CCNA, all those programs are being modified to reflect the new world. It is about more how do you do automation at scale, how can you program that, how can you use API, things of that nature. So we're putting a lot of emphasis so that we can give the new tool set along with that education and the help they need. So that's how we are looking at it. It's more an augmentation. It is not replacing people.
Nick, and from your perspective, you have a very practical application using machine learning techniques. Your customer base, is it like automatic that they get what the value is, and do they see the value, or is that a process that you have to go through as you recruit new customers, et cetera?
It's interesting. When I founded the business, it was 100% skeptics, and they didn't understand the value. They didn't believe the value, and to David's point before, they were, I'm not really sure this is for me. Inevitably, they understand that the automating something to support a human, but in my case, in some of what we do replace the human element. We make it more efficient. Money's not left behind. we see, and now the clients are increasingly seeing, and the majority of our clients at the moment are tech companies. They see that they've got to do a better job. The predictability is a mandatory, not just for the CFO and the street, but their clients want that predictability that something's going to happen. The staff want predictability that they can understand something has taken place, and they can apply maybe what they have learned, if this, then that next logical purchase. They now start to understand. We talk about the nirvana of cross-sell and upsell, and I think pretty much every tech company I go to, after they tell me about cloud computing, they tell me about cross-sell and upsell. It's that contingent, if this, then that. And it's not difficult. It's a simple if and or if then statement. It's not complex to articulate. But for many of them, it's really been difficult to make it work because they've got humans driving that process. So it was skepticism, and now I think people, they get it. But I quickly, when I talk about this stuff to people, I say, you know what? Let me just show you, and I show it, and you have that light bulb moment because the hype, it's not hype, it's real. It's a practical application. There it is.
Thank you. I just want to, a conversation we had at breakfast, David, I'll catch you up in real quick here and throw it to you actually first, is, okay, so we're moving along. There's skepticism about what AI really is and what, but generally it is making its way into applications today. What do we need to be doing about compliance and governance? And, is there enough attention being paid to that? In your view, is that something we need to be worrying about now, or is it all cool?
Well, I don't think that. I'm not a big fan of regulation. I think we have enough already that. To cite a recent unfortunate example, if there'd been machine learning involved in the 737 MAX 8 and Boeing couldn't explain why planes were driven into the ground at 500 miles an hour, it would be viewed as irresponsible engineering in the same way as if the wings had come off. So I don't think any of these things introduce new requirements for regulation. I think they we have enough regulation. In fact, I think we have more than enough regulation. I think that we just all need to be reminded that when we're building real products, that we can't just have a magic black box and defer everything to that. I think that the responsibility still rests with the company, with the engineers, to make good decisions. And I think, again, I come back to predictability, that if you deploy something that's in a safety critical environment and you can't predict how it's going to behave, I think that has to be viewed as irresponsible, whether it's putting a baboon in the pilot's seat or whether it's putting machine learning in control of some vehicle. So I think we just, we need as a technical community just to be cautious that the world hasn't changed. In effect, we're still doing engineering.
Real quick, I'd like you guys to comment on this too, because we had. But before I do that, I just want to know we're going to have a few minutes. So if anyone has some questions, think about them, and we'll come out to you in a couple minutes if you have questions for these guys as well. But any thoughts on
I agree with the statement that's made with David, because if you look at it, you don't want to create closed loop systems which are autonomous in nature, because we are far away from that. It has a lot of interesting side effects, data poisoning, things like that could happen, that the outcome is very unpredictable. So I do believe that you need to have tools which tells what's going on. You need to have a high level system which takes into account the policy and other considerations which activates it in a way where you can do it in a responsible way so that you don't have a system which is off. We believe in that, and that's part of the reason we always talk about you have to be part of the IT ecosystem, and there's already things in place called ITSM infrastructure where you can have policies and others, you can code it. So you really have to give data into it and let it decide based upon the policies and rules of different organizations. Then you have the right way of doing the closed loop, but it's not really closed loop without human intervention in that sense. So that's what we believe in. I am not a big fan of auto remediation in networking. That's really crazy. If you make a mistake, we can bring the whole thing down, like the way of planar you talked about. I would rather give hints and enough insight into what is happening So a higher level intelligence can come in and play a role, and that's more often includes policy because different organizations need to do things differently. So that's what we believe in, and that's the path we are going in.
Nick, anything to add? Yeah.
Everything we speak about when we talk about this has got data as the DNA of this. Yeah. Ultimately, data is the DNA that makes this work. I don't believe we need more regulation or anything like that. I just think we need to probably adhere to what is currently out there. You've got those ISO standards, you've got those things. For core things like data and the security and the policies around the management of that, I think we're probably good enough. I think we're so nascent, I just don't think we know enough to know what we should regulate and how we should regulate it. And when we're talking about AI, and we're talking about this machine learning stuff, really what it is distilling the essence of what a human has asked the machine to do and making sure that it does it in a way which is predictable and verifiable and all that type of stuff. And that doesn't require over-regulation. I think it just requires adherence to the rules we've currently been living by.
David? Yeah.
I had one comment here. I think besides figuring out where to apply this, I think we're still trying to understand where we are with some of this technology. And one of the examples I like is there was a lot of excitement that a colleague of mine, Fei at Standford, released this collection of images, something like 2 million images. And there's been these contests, if you like, of having machine learning systems recognize these different images. So there's a lot of excitement about the accuracy of that going up substantially. And, you know, for instance, that it could recognize a wolf versus a dog. Now, what I understand recently is people discovered that the reason it was telling the difference between a wolf and a dog was that wolves were in a background that was snow and bushes, and dogs were in a background that was grass. And the point of this is that we thought we were further along in solving this problem than we were. And another example that came out was that some work at Google demonstrated that in recognizing a zebra, it was very significant in the machine learning that there was grass involved. So you'd have a system which would recognize a zebra, but if you put a zebra in a parking lot, it wouldn't recognize it. And so I think, you know, we're still discovering these sort of effects that are hidden in these data sets. And I'm not faulting anybody, I'm just trying to illustrate that we can think we're further along than we actually are at times.
That gets to the point, Ravi, you were making earlier about the key thing being data and data fidelity.
Yes.
And integrity, and then it kind of builds from there, right?
Yeah.
Yeah. Any questions from Scott?
Hi, Scott Rainish, Futurium. A couple interesting points. Jerry, you made an interesting point about applied AI, and it seems to me like AI works with very simple applications. Well, even sometimes it doesn't work. Like Siri, to me, still doesn't ever work. But like Shazam is amazing to me because I'm a music fan, and it seems to be flawless and recognizes a song within a number of seconds. And then as we get it up in complexity, it seems to be where AI falls apart. Like David was referring to the Boeing mess, which actually seems more like an engineering and management problem rather than an AI problem, but an airplane is more complex than a search engine or a music search engine. And then we get into cloud, and we're seeing this presentation about AI and networks, and the complexity increases by order of magnitudes. You have machines talking to machines on different levels, different domains, cloud domain, virtualization domain, hardware domain, and that's where things fall apart, especially with interoperability, right? Because when you talk to IT people, their problem isn't, oh, I have this magical AI engine that will fix everything. Their problem is getting things to talk to each other and having the data sources interoperate so that you can apply the AI. So my question to the panel is, aren't we just going down the wrong rabbit hole? It's really about getting the systems to interoperate and have clean data so that we can build AI machines that will actually do what we're talking about that's not happening today.
So I can comment definitely around the data cleanliness problem. Like, you know, the challenge we have got is just data is really not clean. We look at certain counters and think that's fine. You cannot compare them because they come from different versions of the same operating system or different products, and they are not comparable. So there's a lot of challenge that's there. And we are facing that because we are just, as you start using data and ML, you start realizing those play a big role. The small deviations lead to a very different conclusion unless you take those into account. So for us, that's a big challenge in how do you bring data which is clean, consistent, they are comparable, they are what they are across different versions of software, different products, and even different vendors and different parts of the infrastructure. And that's a big challenge. So data fidelity and ability to use it consistently and how do you bring this data together is a far bigger challenge than applying some simple algorithm to that. So that trips us often. What we think is the right answer is not necessarily right as you go to different data set, and that's a big challenge. And that's why we have to be very careful. We have to thoughtfully use it and keep using the term it's an assist. It's not a replacement exactly for that reason.
I guess I would dispute your characterization that AI runs out of gas, at least the techniques we're talking about with complexity, because I think if you consider, say, the problem that Google tackles of how do you do a search for images of cats, for instance, that it's a complex task to figure out what is it, starting from pixel level, what's a cat? And so, they successfully applied that. I think and it's sort of pretty predictable in the sense that most of the images you get back are cats. Now, I think that as machine learning as a statistical technique can handle extremely complex things, when you have enough data to train it on, and also when being mostly right is good enough. And so with cats, you say, well, gee, this is great, Google. I can search for images of cats, and 9 out of the 10 pictures you show me are cats. I think the area where it gets difficult is when the statistics are working against you, where you say, I'm looking for some anomalous situation, and if it's only right 9 out of 10 times, and I'm having events occurring at basically trillions of times a second in a large network, the statistics work against you, and if that filters all the way up to alerts or any action by an operator, it leads to being overwhelmed by alerts. And I think even Google has a great technical paper where they describe the difficulty of composing machine learning systems, because we compose an engineering system by having clean, well-defined interfaces that have semantics across them. When the internal guts is something that does unpredictable things, we can't compose them in a reliable way. So I think that there's a composability problem we haven't solved.
We have a question over here. I think we have one here too. Yeah, go ahead.
Yeah, Steve Cassidy, PC Pro. An interesting gap in the topics you guys have been covering, which devolves from observing the problems with things like Bitcoin. And that is that AI seems to be counted as a free resource. Nobody has any sense of whether a solution is expensive, either in compute terms or in dollars and cents sitting on EC2, right? Or whether it's actually a really cheap, easy fix that just happens to be quite intricate and quite a lump of logic. How can businesses predict the costs of AI in their development exercises?
Any thoughts on that?
Well, I think there's the cost of running it is highly predictable, because it's basically just doing classification in real time, so to speak. So you can determine that just by building the system and running it. I think the data collection, there's at least, you can scope this reasonably based on experience. What I think is harder is to understand in certain domains how much it's going to cost you to maintain it or deal with unpredictable problems. And I think that's where, end up, that third piece, I think, is the part that I think is harder to capture, of just, if we build this thing, how much how many times are we going to have problems where it does something we didn't expect?
All right, I think we're going to have to wrap up. Thank you very much. Please join me in thanking David, Ravi, and Nick for their comments. Thank you very much. Thank you.
Thank you for listening to this NetEvents podcast. A full transcript is available from www.netevents.org.